So I just to limit it so that I realize I have shit.
Okay, all right. Hi, hello. Big things happening. What they wanted to today, so kind of what we're doing is kind of difficult. We're a little bit behind, so the project is not really there yet because you need to do lab first. So what I want to do is, again, kind of review on a high level, review strings, then continue the strings and structs example from last time. We'll then kind of circle back and do the pointers worksheet. And then we'll do blocks of structs, which kind of combines everything from here together. So again, two different things that you can do with strings. And this applies to any kind of block of data, right? So you can have just an address and say that at this address, I'm going to store the characters, right? So what you cannot do is you cannot say, well, like this is just a random address that's not initialized, and then I'll write A to name it 0, and I'll write L to name it 1, and so on. Does it make sense to people that this would not work? Does it not make sense to anyone? Right, so the issue is if name is not any address in particular, you cannot just say, I'll write A to name it 0, because there's no such thing as name it 0 currently. Make sense? So you can fix it by saying, oh, I'll make name be something that actually exists. So the way I'll do it is I'll say, malloc, please send me an address where I can write 100 characters. Is that making sense? So at this point, I can do it. At this point, I could say, okay, like name, it didn't used to be a valid address, but now name is a valid address. So now I can write A and L and I and C and so on to name. All right. I can then say, well, instead of writing, capital A, I'll overwrite it with lowercase a. That's fine. I can do something like this. So this is saying put a string somewhere and then make name refer to the address where the string is stored. Right? So the distinction is here, you're first saying name, make it be an address where I can write 100 characters and then write the characters that you want to write there. Here I'm saying put Alice somewhere in memory and then say, well, name is now the address of the A from this string. Make sense? So the only problem with this is that's a memory leak. So that's if you take this block of code as continuing here. Here you said, I want name to be the address of a memory block that malloc gave me. And now I'm saying overwrite name with a new address. So that means that whatever is the address that malloc returned here is just lost. Yes. Yes, so a memory leak refers to allocating a block of memory and then not freeing it. So if you allocated a block of memory using malloc, that means that the program does not get to use it for anything else. If you keep allocating and you don't free, eventually you'll run out of memory that you can allocate. Yeah.
What does it mean, free memory?
So freeing memory, if you remember, that is this. So freeing memory means saying to the computer, you can reallocate that block of memory for something else. Right? So the program basically keeps track of what's allocated, what's not allocated, and it can allocate memory blocks for new stuff if there is memory available. Okay, well, right. Okay, so anyone, why could the last line lead to a crash? Yeah.
Now that's like converted to a
So not exactly converted, right? So the issue is that this guy could be write-only memory, read-only memory, right? So that means that it could be that you compile this program and you're not allowed to modify this A at all because that's how string literals work in C. Right? Yeah.
But string literals.
Yeah. Yeah, so the distinction here, I think what you maybe want to ask is, okay, like there's two different things here. There is like, what is the type of this thing? And the type is const char star. The type means that if you were to keep it as const char star, the compiler would just not allow you to do this. The issue is that here we said name, which is of type char star is equal to Alice. So the compiler is not going to catch the issue. So you can't say it will compile. If you say name at 0 is equal to A, that will compile. The issue is that string literals could literally be read-only, which means that it would crash when you try to modify it. With that said, it could crash. It's really undefined behavior. All right, does that make sense? So, okay. So the other way you can store a string is you can say, I have a character array. So here it looks the same, but it's not the same as before. it looks like you are putting a string literal in here. It's not. Really, this is just shorthand for this. So here, what we're doing is we're defining a character array, size 200, and then we are, initializing it with BOB and then null. So character arrays you can modify. That is fine. This you just cannot do, will not compile. You cannot reassign to arrays. So you can modify individual elements of arrays. You cannot say name is something new, just does not work in C, will not compile. Yeah.
Does that mean you have malloc 200?
No, it does not. So this is a character array, which means that it's an array. It's a local variable that you're defining somewhere. So it's like 200 slots that you get. Malloc is a separate thing. Malloc is a block of variables. Yeah.
Well, when you write the character name you are going to close Bob, so that means that there's just 196 slots that are just empty.
Well, so there's no such thing as empty in the sense that every slot has a value. I do not, I think someone asked me before, so I do not believe that it's in the standard that everything is just filled out with nulls. In practice, it would on modern compilers be filled out with nulls, but the values could be anything. It's just the same as saying, car name 200, not initialized. And then the first 4 characters are BOB and then null. Make sense? Yeah.
So, I'm gonna get into this, but in terms of like memory, like what's the difference between an array and just a block of variables?
So an array is a kind of a block. So the difference is an array is defined within a certain scope, so ordinarily within a function. So an array is a local variable. It goes away when the function finishes running. A malloc allocated block, on the other hand, does not go away until you explicitly free it or the program finishes running, the entire program. They are, but we have not gotten to that. So they're stored differently in the sense that they're stored in kind of different places. We'll get to we actually have seen that, and we'll get to the example again. Yeah.
So if you initialize like a malloc block in one function, you can still access it in another function.
Correct. Yeah. All right. So that's strings. And what we started doing last time was strings inside structs. So you can do it 2 ways. So you can say inside the struct, and this is to your question. So inside the struct, we can store an address of the first character, or we can store the entire array. Like so. So let's go back to the code from Thursday. So here's 2 things that we could do. So we could define a student like this. We could define a student like this. So here, what I want to do is I want to make something, make something like this, right? So I can say student S1. So now let's say that I want to assign this name to this name. How could I do that? So I could say, okay, I've defined S1. So I can now say S1.name. So I can say is equal to name like so. And I can say whatever S1.GPA is equal to GPA. So, and then I can say return S1. So here, what I did is I created the student as 1, and then I assigned the name here, and I assigned the GPA here, and I'm returning, the address name and the GPA packaged in one struct. Okay. So let's say that they do that. So I'll add make student here. Do it over here. Right. Does this make sense? So I'm passing the address of the M here. So the address of the M is going to be a name, and I'm passing 3.7 into GPA. Right. And then I'm making S1 not initialized yet, and then I'm doing this. So this is just copying name, meaning copying the address to s1.name, copying GPA to s1.gpa, and I'm returning s1. So here, let me just print. Like so. So that is supposed to print, right? Just remove the breakpoint. Oh, I'm in a different. Okay, so here the issue was that I'm currently running useTune. So if you remember, what I need to do is go to configure tasks. And now what I really want to do is run the current file again. And that is what's happening by default. So I just did configure tasks. And now in this folder, this is what's going to run. So if I run this, and if I add this, that is now fine. And that prints Mike as intended. So one thing that they cannot do here is say s1.name at 0 is equal to lowercase m. Okay, so does it make sense? What happened here is I passed the address of the string literal here, and then I just assigned it here. So that means that if I go to the address of the capital M here, I'm not allowed to change it. Does that make sense? Yeah. So it's read only because if I input things as string literals, they are read only. Right. So what happens here is I'm passing so I inputted this not as an initialization to the array, just as a string literal. String literals are read only. So what I'm passing here is the address of the M is being passed to name. I can print it, you can read it, but you cannot write to it. Does that make sense? So here's a different way of doing this where I could do it. So I'm copying and pasting. So if instead what I had done is said, I'm gonna malloc this guy. And then I'm gonna copy to it. So that's going to be the same, right? Except now what I did is I made this name be an address of just a block, which I can modify. So if now I say, something like this is completely fine. So the difference is that this makes student one, call it new. So what this does is it creates a new block of memory to store the name and then store the address of the block at s1.name and then copy name to the address s1.name. So that makes it so that I can actually modify s1.name at 0, for example. Is that making sense? Questions? All right. So that's student. That's student one. So with student two, we don't have this issue because this is just name at 200, right? Well, sorry, not name at 200, but like a character array. So character arrays you are allowed to modify. So I'll just make student two. So here, what do we need to do? So we cannot reassign to arrays, if you remember, but we can copy into arrays. So what you would do is you would say strcpy So the difference is s2.name is an array. It's already allocated. You cannot reassign to arrays. So that's not a possibility, but can write to arrays. Does that make sense? And I realize it's a lot, but it is what it is. There's going to be a lot of practice. But the basic rules are all on the first page of the handout that you got. So technically, everything is there. Yeah. Why we're using. Yeah. So because that's the only thing we can do, right? So s2.name, you cannot reassign arrays. So you cannot say s2.name is equal to something new. That will just not compile. If what you want to do is store the string in s2, the only thing you can do really is strcpy. I suppose you could just do a manual loop as well. So this would just not compile. So not an option. Make sense? Yeah.
So the string copy is literally just saying str.name at 0 equals name at 0.
That's exactly right. So strcpy is equivalent to, for I equals 0. So you don't need to copy it. This is just in response to a question. So those are just like literally equivalent. And that's the only thing that you can do with arrays because that's how arrays work. Right? Makes sense? This shouldn't exactly make sense because it's a lot of stuff. But what the plan now is, well, kind of having kept that in mind as a goal, I now want to do a few kind of simple exercises, and then we'll go to blocks of structs, and then there's going to be exercises in the lab as well about that. So, okay, all right. Let's go to the first exercise on the handout. Yeah.
What was the code trying to do?
So the question was, what is the code trying to do? Well, like this is just like essentially manually initializing the students, right? So I can now, for example, print s1.name, right? So like the point is to make this s1, where I initialize it, with this and this. And you might ask, like, couldn't you do it like automatically? And the answer is, for some situations, yes. For some situations, no. So if you say student S1 so you can do it, but this would be equivalent to make student, not to make student new. Make sense? So the point I'm trying to make is, so this and this are different. The way they're different is what's going on over here. And there is not a way to, so there you can do this, but you cannot do this using the C initialization syntax. Yeah.
Henderson initialize structs like using the brace notation.
I mean, you can, like this is fine, and this would be equivalent to this, but not equivalent to this. Right? Yes, there is an online version of the handout. It is I think we're skipping stuff a little bit. Wait, did I not? Oh, yeah. Yeah, slide 89. Okay, all right. So let's do the handout, and then we'll do blocks of structs, and hopefully we'll be ready for the lab. So I'll give you like 2 minutes to okay, sorry, a little bit short in time. So I'll do the first question myself, and then I'll give you time to work on the second question. going on here? Okay, so like we're essentially doing like Python tutor, but manually here. So unlike Python, there isn't really a variable table, right? So all C has is a memory table where all the variables are stored. And the way it works is, unlike in Python, saying equals 15 just means copy 15 to wherever A is stored, right? So there's not an indirection where you also have a memory table. So what that means is there's going to be some cell that's the local A in main and some cell that's the local A in F. And what's going to happen first is 15 is just going to get copied into the local A in main. What happens here, again, according to the rules, is the contents of this get copied to the contents of this. So what that means is you're taking this guy and it just gets copied to wherever the local A in F is stored. This means the 5 gets copied to the left-hand side. So this used to be 15. And now it becomes 5. Return 3 means we are copying this guy over here, right? So the value of f of a is 3, and 3 just gets copied to a. So that means that the local a in main becomes 3. Yeah.
Oh, and see, basically in this memory table, each address is associated with a variable.
That's correct. So well, sorry, not each address is associated with a variable, but there's some addresses that are not. But yeah, like a variable essentially gets assigned an address. Yeah. 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 Oh, that's just a typo. Thank you. Yeah. All right. Okay. So let's try this one. And I'll give you 2 minutes to kind of write it and try to kind of follow the rules if you're. So like, I think this one is not kind of ambiguous, but yeah. 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 Graceful. It's not. It will be in, like, yeah. Yeah. It's not. I mean, it is on my end. All right. Oh, okay. Okay. Yeah.
I don't think we realized there were two sheets.
Oh, okay, yeah. Just if you take two in a row, if one of them is going to be the right one. All right, so let's try to do this. So again, this would be kind of A, and this would be PA. So this would be local to main, and this would be local to F. And again, just kind of always kind of copy right-hand side to the left-hand side. So 15 gets copied to whatever is assigned to A. We are now saying F address of A. So that means, thank you. So that means that we're computing address of A. So address of A is 1032. So 1032 gets copied to PA. So the value of PA is going to be 1032. We're now saying star PA is equal to 5. So take 5 and copy it to address 1032. So that means that the 15 becomes 5. And now we're saying return 3. So 3 gets copied into A. So this is 3, and that gets copied into A. So that means that this becomes 3. Make sense? All right, questions about this? So kind of the way, again, I think so two ways to think about it, I guess. So one way is just kind of recognize the pattern. And as you practice with it more, you'll start recognizing the pattern better. Well, like if you send in the pointer, so if you send in the address of A and then you say start PA over here, that means that you're changing the value of A. So that is how I think about it. I think once you kind of write more code, that's how you think about it. The other way to think about it is like literally, okay, like you're always copying the right-hand side to the left-hand side. So the right-hand side here is 5. The left-hand side here is star PA, which means the cell at 1032. So that means that it must be that you're writing 5 to where A is. Over here, again, kind of you're returning, that means that, thank you. So this means that this whole thing is 3, and you're copying 3 back into A. So that means that the A becomes 3. Okay, is that good? All right, last one. This was all copy pasted, so it's all void.
Nothing is.
All right, so let's look at this. So this one is the same again. So just right hand side gets copied to the left hand side. This one is saying same thing. So address of A 1032 gets sent to PA. So that means that PA becomes 1032. Now we're saying, get me a block of memory that's something and assign it to PA. So again, take this and copy it to PA. So what is this? Well, it's some number. We don't know what it is. It's the address of a new block. Right? So that means that this becomes something. Maybe like, I don't know, like, doesn't matter. Right? And then we're returning 3. So that means that the value of this is 3, and that gets copied to A. So this becomes 3. So this doesn't really do anything because PA is a local variable. You've allocated the block, and then you didn't really use it for anything. Yeah.
1032 just randomly becomes something else.
Well, it's that malloc returns the address of a new block where you can write stuff.
Okay, so it's like it becomes a new block that.
Well, it doesn't, it becomes the address of the block, right? So malloc returns the address of a block where you can write stuff. Yeah.
We have like in our memory table written like pick one of those addresses to be the first element of the malloc block.
So the malloc, so you could, I mean, I kind of did. So like here, I just made it be 4020 rather than, 1048 or something. I could choose to make it 1048. Yeah.
where a bunch of other specifiers are?
So a memory block is, a bunch of cells in memory. So malloc returns the address of the first cell. The idea is that malloc returns the address of a cell where you can write stuff.
That's for science. TA now just the first cell, the first. Okay, of that one.
Yeah, it could be, we're not using it here, but yeah. So we're just not using it, right? We're just like reassigning PA, but we are then not using PA for anything. All right, there was a question somewhere? No? All right. So let me now do the So let me do the block of structs thing. So here I'll just do the usual kind of thing. So I can do something like this. I can also have an array of students. Okay. And that's the same as saying, in the same way that you can have an array of numbers, you can have an array of students. So an array of those kinds of guys. You can now say something like students at 5.name. And I want to copy Bob into students5.name. Does that make sense? So in the same way that we before had s1.name, you can also have students at 5.name. Does that make sense? So is that good with people? So the analogy here is that you could say, well, that was already there. So you could say this, and in the same way, you can say this. So the issue from before is that if you're doing a student2 kind of deal here, you now cannot do this, right? So you can still say students2, students2 like this, but you cannot do this directly because in 2s. Because it's not a valid address. Does that make sense? So what you can do is say, okay, so the name is something like this. And now this is fine. Does that make sense? Now, so this is kind of annoying because here what I did is I had to allocate specifically the one, specifically kind of this name. So maybe what I want to do is I want to create, a block of 200 students where all the names are pre-allocated, right? So how would I do it? So I'm making this student 2 block, I guess. So I'll say, okay, so student 2 is going to be this. So because I'm returning this, this has to be malloc. This cannot be an array. So I'm mallocing this much space, so enough space for student 2 times n. And now if I want to pre-allocate, what I'm going to do is I'm going to just go through every student 2 and pre-allocate the name, right? So I'm going to say for int I equals 0, I smaller than n, I plus plus. And I'm just pre-allocating 200 characters or something. Does that make sense? Yeah. So because I'm about to return students. And that's of type student 2 star. Yeah. All right. Now, if I've malloced a whole bunch of things, I also want to free it. So that's going to be the last thing. I'm sorry, I'm going to take 1 more minute. Destroy students, aka calculus. So here, what I got to do is everything that was malloced, I also want to free before I'm done, right? So the way I would do it is, so I'll just copy and paste this. And I'll just free the name for every student's I. After I've done it, I can say free students. Right? So the idea is if I've allocated every name, in order to free it, I first need to free every name. And then after I've done it, I get to say, okay, now the students are no use to me. You can go. Bye. Goodbye. Yeah.